Today's notes are on 3.1 measures of center. So we are actually in the midst of beginning a new chapter in the book, but we're still in our second unit. So this chapter is dedicated to descriptive measures. So we'll be talking through different ways to talk about our descriptive measures and then display those. So the first lesson then in this chapter is focused on measures of center, or also known as measures of central tendency. And these measures are descriptive measures that indicate where the center or most typical value of a data set lies. The three most important measures of center include mean, median, and mode. So much of this lesson may be review, and some of this lesson will likely be new for everyone. So our first example is about mean. The mean of a data set is the sum of the observations divided by the number of observations. So in this example, we're talking about weekly salaries. Professor Hassett spent one summer working for a small mathematical consulting firm. The firm employed a few senior consultants who made between $800 and $1,050 per week. A few junior consultants who made between $400 and $450 per week, and several clerical workers who made $300 per week. The firm required more employees during the first half of the summer than the second half. So you can see tables 3.1 and 3.2 list typical weekly earnings for the two halves of the summer. So find the mean of each of the two data sets. So we'll start with table 3.1, or data set 1. So we'll add up each of the 13 observations, and when you add all of these up, you get $6,290. And there are 13 observations, so we'll divide by 13. When we do that division, we get $483.85 when we round to the nearest hundredth, or the nearest cent. Looking at data set 2. And we add each of these observations, we get $4,740, and there are only 10 observations in this set, which divides out to get $474 exact. So what can we observe then, or interpret from this information? Well, we can interpret that on average those employed in the first half of the summer earned more than those employed on the second half, So it's always good, after you calculate your measures of center, to go back and consider what they actually represent. So on average, those working the first half made more than the second half of summer. All right, so next we'll talk about the measure of center, median. So we talked about mean, now we'll talk about median. The median of the data set is the number that divides the bottom 50% of the data from the top 50%. So the first step in this process is arrange the data in increasing order. B, if the number of observations is odd, then the median is the observation exactly in the middle of the ordered list. But if the number of observations is even, then the median is the mean of the two middle observations in the ordered list. So let's look at an example here. Weekly salaries. Consider again the two sets of data shown in tables 3.1 and 3.2. Determine the median of each of the two sets of data. So we'll list these out in order. Let's see if I can all on one. So set 1. So we've got 300, mostly 300s here. 1, 2, 3, 4, 5, 6, and then 400, 2 400s. We got 450, 2 450s. 800, 940, and then I should have started over to the left further. 1050, that's our last one. So if we go down and cross out numbers till we get to the middle, 400 is our median. And then data set 2. Similarly, only we have 10 observations this time. So we have 5 employees now making $300. 1, 2, 3, 4, 5. 2 making 400. 1 making 450, 1 making 940, and 1,050 as our top paid employee once again. And we find the middle, and it happens to be 2 numbers. And so in order to calculate the median in this case, we add these together and divide by 2. Find the average, and we get 350. So our median in this case is 350, or $350, I should say, and $400. Finally, we have the mode as our third measure of central tendency. And the mode of a data set is the value that occurs most often. It happens occasionally that there is no value that occurs more than once, and in that case there would not be a mode. And then on occasion you have a data set that will have more than one mode if more than one of its values occurs with the greatest frequency. So we'll take a look at an example here. And just by scanning through, you can see we have 3 400s. 1, 2, 3. Oh, there's 4 400s. And looks like we have 1, 2, 3, 4 300s. So that means we have 2 modes, which would be, I'll list them in order. So $300 and $400. Another example here, weekly salaries. Determine the mode or modes of each of the 2 sets of salary data given in tables 3.1 and 3.2 on page 94. So it looks like we have a frequency distribution of data set 1, and so it's fairly obvious that there are 6 $300 a week employees, and that would give us our mode for set 1. Mode is $300. And then look back real quick for set 2. We've already written these in order, so it's again easy to see the mode is also $300 for data set 2. On to another topic, choosing and displaying measures of center. It can be a challenge to decide what is the best measure of center for a given data set. So first of all, to display, when we're displaying measures of center, you can see these skewed data distributions or the symmetric data distribution and where the mean and the median lie with respect to one another. So if you have a right skewed or positively skewed data set, you can see that the median is to the left of the mean. Whereas in symmetrically distributed data sets, we have the mean and the median in the very same spot. The middle number and the average are right there in the middle. And when you have the negatively skewed or left skewed data distribution, the mean is lying to the left of the median. So choosing the appropriate measure of center, another important topic. So resistant measure is not sensitive to the influence of a few extreme observations. The median is a resistant measure of center, but the mean is not. So for example, selecting an appropriate measure of center. A student takes 4 exams in biology class. His grades are 88, 75, 95, and 100. Which measure of center is the student likely to report? Very practical for our school situation. What would we report? Well, typically we report an average when we're talking about grades. Right? So we would add all of these together, divide by 4, and get 89.5. And you can see 89.5 does a good job of finding the center of that data set. B, the National Association of Realtors publishes data on resale prices of U.S. homes. Which measure of center is most appropriate for such resale prices? Well, in this case, the most appropriate measure of center is the median, because it is aimed at finding the center of the data on resale home prices and is not strongly affected by the relatively few homes with extremely high resale prices. So the median provides a better indication of the typical resale price than the mean or the mode. So for part B, we would put the median. Again, we would have the tendency for some extremely costly homes that would be kind of our outliers and would throw off our measure of center if we use the mean. Part C, the 2014 Boston Marathon had categories of official finishers, male and female, of which there were 19,579 and 16,092 respectively. Which measure of center should be used here? And in this case, you can't actually compute the mean or the median because we're talking here about qualitative data. So the only measure of center that we can use is the mode. So again, with qualitative data, that's important to note. The only measure, only measure of center we can use is the mode with qualitative data. Lastly, summation notation and the sample mean. So we actually use a Greek letter, the sigma, to indicate summation or the sum of a set of numbers concisely. So the I think this actually belongs with the previous section, but the median is preferred for data sets that have extreme observations. Whoops. And that probably goes up here with this section. Here's an example then using our summation notation. Exam scores. The exam score for the student in example 3.4a are listed. Use mathematical notation to represent the individual exam scores. So in this case, we would label each of our observations with an X and a subscript. So X sub 1 indicates our first value, which is 88. X sub 2 indicates our second value, which is 75. X sub 3 would be 95. And then X sub 4 is 100. So this is part A. And then, so those were our individual scores, and then use summation notation to express the sum of the 4 exam scores, and in that case, we would write the sum of all X sub I, the sum of all of our exam scores, would be X sub 1 plus X sub 2 plus X sub 3 plus X sub 4. In other words, 88 plus 75 plus 95 plus 100, or 358. Now we have a mathematical way, a mathematical notation also for mean. So for sample mean, it's a little hard to see, but you can see this equation here. X bar equals the sum of X sub I of all of my values divided by the number of observations. So N in this equation is the sample size. So this is a key formula we will be using starting now through the rest of the course. So here's our last example. Children of diabetic mothers. The paper correlations between the intrauterine metabolic environment and blood pressure in adolescent offspring of diabetic mothers. Okay, so you can see we're just talking about, here's the title of our article, and here is our source, the Journal of Pediatrics. And here's our author. Presented findings of research on children of diabetic mothers. Past studies showed that maternal diabetes results in obesity, blood pressure, and glucose tolerance complications in the offspring. So you can see table 3.5, this is table 3.5, presents the arterial blood pressures in millimeters of mercury for a sample of 16 children of diabetic mothers. Determine the sample mean of these arterial blood pressures. So we'll use our mathematical notation, and X bar equals the sum of all of our observations, X sub I, divided by the number of observations. So when we add all of these together, we get 1,378 and 9/10, and there are a total of 16 observations. And so our X bar, or our sample mean, equals 86.18. So this concludes our notes on measures of center.